Okay, class, picking up where we left off at, we were on problem number 20. It says use the formula you wrote in question 19 to find the future value after 20 years of a $5,000 account that earns 4% interest compounded continuously. Then compare that to the future value of the same account if interest is compounded annually. Okay, so we'll start off with continuously. So A is equal to P times E to the RT power. So A is equal to 5,000 is the principal. Then we will have E, R is 0.04, and T will be 20 years, or 20. Now when you put this in your calculator, you have $11,127.70. Now we would do the annually. A is equal to P times 1 plus R over N to the NT. A is equal to the principal is 5,000 times 1 plus 0.04 over 1 to the 1 times 20 years. So we know that would be 20. So our answer here would be about $10,955.62. To compare this, we get more interest with compounded continuously. Okay, number 21. It says, finally, let's compare interest compounded continuously to simple interest. Suppose that $50,000 is invested in two accounts. One earns 6% simple interest, the other earns 6% compounded continuously. Fill in the table with the future value of each account after each term rounded to the nearest dollar. Wouldn't this be a great spot to use a spreadsheet, or at least a table feature on a graphing calculator? Okay, so we will get to the table feature on the graphing calculator. But first, let's write out what the formulas would look like for the simple interest. First of all, the formula for simple interest would be A is equal to the 50,000 times 1 plus 0.06t. And then the compounded continuously would be A is equal to 50,000 E times 0.06 times t. So now we know we will substitute these values in for t. Okay, now for this problem we're going to need our calculator so we could put this in the table. Now we could go through and then type in 5 and 10 and 20 and 15 into t and putting all this in our calculator over and over again. But it'd be easier to do it in the calculator. So press the Y equal key and type in the first equation without the A. So we'll type in the 50,000, parenthesis, 1 plus 0.06, and instead of t, we'll use x, and close your parenthesis. Now we would do the second value. It would be 50,000, and then we would do E, which would be second, and then the ln key, which is the natural log key. And then type in 0.06x instead of t. Now, what we would do next, we don't have to graph this. We would just press second, then graph. And it would give us this table. Now remember, the first table is our simple interest. The second table is our continuous interest. So we want to go down to 5. And for simple, we're going to have to highlight both of these because sometimes it had decimals that we don't see. So the first one would be 65,000. And then for the continuous, it would be 67,400. We'll round to the nearest whole number, so we don't have to highlight it. Okay, we'll go down to 10. It'll be 80,000. And then 10, it'll be 91,106. And we can go to 15. Now, instead of going all the way down like this, there's another way we could do this. if we go to second and then we go to window and go down to ask and press enter for the independent, then we press second and graph. Now we could just type in the numbers. So let's type in 15. That'll give us 95,000 and then 122,980. Then we could type in 20. That would give us instead of 110,000 and 166,006. Type in 25. That'll give us 125,000 and then 224,084. And then type in 30. It'll give us 140,000 and then 302,482. Now, this is our final answers here. And then now, because a lot of you may like the automatic feature to turn your calculator back where it will automatically give you values in this table, you will press second and window and go back down to auto and press enter. So it would start you off with the automatic values. And we could check it by pressing second and graph. And then now it gives us the automatic values. And we are done.